sine x divided by sine cubed x is equals to sec x over 1 plus cos x here. So here we're going to show that the left hand side, this side, is equal to the right hand side. So this simply means that we first start by simplifying what we have on the left hand side, we work it out up until we get what's on the right hand side. Then we prove that this trigonometric identity that we have here holds. So let's start with the left hand side. This side, so we have tan x minus sine x divided by sine cubed x like this. So we know that tan x is an identity that is made up of sine x divided by cos x. So we make that substitution there. So here we have sine x, sorry, let me just erase that. Okay, so here we have sine x divided by cos x minus sine x. So this is the numerator here. Then everything we divide by sine cubed x like this. So then on the numerator here we make it a mixed fraction, or a single fraction rather. So we have the common denominator there. It's going to be cos x like this. Then cos x into cos x, we get 1 times sine x, we just simply get sine x there like this. Then here this is sine x over 1, so 1 into cos x, we get cos x multiplied by sine x there, we get minus sine x cos x like this here. So then when we change this division sign here into a multiplication symbol, we're going to have times 1 over sine cubed x like this here. So then here, let me just do this. So if you look at these terms here, we can factor out sine here because it's common in the two terms that we have there. So if we factor out sine x, so we're going to have sine x, open brackets, we have 1 minus cos x like this here, divided by sine cubed x and cos x like this. So then if we divide a single sine x here into one of these here, so you know that here we're going to remain with 2, then this one will go there. So here we're going to have simply 1 minus cos x divided by sine squared x, and we have cos x like this here. So now the next thing that we're going to do here is we rationalize the numerator that we have there, so meaning that we find its conjugate, then we multiply it by the whole expression that we have here. So finding the conjugate, we not say that the conjugate is going to be 1 plus cos x like this. This side the same thing happens, we also have 1 plus cos x like this here. So we begin multiplying this term by that term, this term again by that term, and so on and so forth. So then there, 1 multiplied by 1, we get 1 multiplied by cos x, we get cos x like this. Then negative cos x multiplied by 1, we get negative cos x. Then negative cos x multiplied by positive cos x, here we get negative cos squared x like this, divided by sine squared x cos x, open brackets, 1 plus cos x like this here. So let me just scroll down a bit. So then here you notice that cos x and negative cos x there will cancel out. Then on top there, we're left with 1 minus cos squared x divided by sine squared x cos x, open brackets, 1 plus cos x like this here. So what we have here on top here comes from a Pythagorean identity there. So we state where this comes from, then we make that substitution there. So here we say, since we know that sine squared x plus cos squared x is equal to 1, then if we make sine squared here the subject, we're going to have sine squared x is equal to 1 minus cos squared x like this here. So meaning that where there's 1 minus cos squared x here, we make a substitution and put sine squared x like this here. So then we're simply going to have let me just scroll down a bit. Okay, so we're simply going to have sine squared x divided by sine squared x cos x 1 plus cos x like this. So sine squared x and sine squared x are going to cancel out, so it's just left with 1 divided by cos x, then we have 1 plus cos x like this here. So this here is the same as 1 over cos x multiplied by 1 over 1 plus cos x like this. So then here we know to say that 1 over cos x is an identity there, so meaning that this is just going to be simply equal to sec x like this divided by 1 plus cos x like this. So if you look at this, this is equal to the right hand side that we're looking for there. So here, therefore, we've proved this trigonometric identity that we have there. Okay, let's go to the next question.